I welcome you all learners to this video session. So in this video session, we would like to discuss about building blocks of algorithms. So this building blocks of algorithms is coming under the first unit of problem solving and Python programming course. As far as building blocks of algorithms are concerned, we wanted to explain what is a statement, what is a state, and what is a control flow and what are the control flow operations, that means the statements and then functions. And one more input I would like to give you here. So in this topic, building blocks of algorithms, so the statement, state, control flow, functions were explaining. The same answers for strategies for developing algorithms also. So here wanted to give more explanation about the sequence structure, selection structure, iteration and recursion, and all these structures are coming under control flow. And the same answer for algorithmic problem solving methodologies also. So university examination, if the question asked either building blocks of algorithms or algorithm problem solving or strategies for developing algorithms, the students expected to explain all the concept, statement, state, control flow and functions. Particularly the control flow wanted to focus much under various strategies for developing algorithms. So like this only, this video will take you to learn this topic. Okay, first I would like to highlight what is the building blocks and how the building blocks, okay, is helping to develop a very good algorithm. So whenever you are calling as algorithm, it is a set of instructions and instructions wanted to execute in sequence manner so that the best solution we will get. So in our previous videos, we discussed about algorithms and has given different definitions and the justification also. Here in the building blocks of algorithms, it has two broader sections. One is called heading section and other one is called body section. The heading section is nothing but where we can highlight what is the purpose of this algorithm we are developing, for what purpose and what are the objectives, what type of input we will give, what type of output we are expecting, and like this, okay, there's some information we can give under what is called this command symbol. Okay, so that's coming under heading section. And the second part of this algorithm is body section. It's a very important, that is a core part of the algorithm. Okay, as far as body section is concerned, it consists of a few statements. The statements also called as instructions, you know, and the second one is a state, and then body section consists of various control flow statements like sequence control flow statements, selection control flow statements, and iteration or looping control flow statements. And further, the body section of an algorithm may have functions, one function or numbers of functions. And like this, okay, all the topics we will discuss one by one. And not only that, the building blocks of algorithms, the question was asked in January 2019. Okay, first we will talk about what is the statement or what is the instruction. As far as statement or instructions are concerned, it is the finite number of statements. That means, so if an algorithm we are developing, the algorithm may consist of 10 lines, that means a 10 statement or 25 statements or 100 statements, any number of statements, but the finite number of statements. So see the one example here, okay, that is a statements, first statement, second statement, third statement, and the fourth statement, and like this it is a finite state. And not only that, the algorithm should be executed in order. Okay, the ordered form is very important one. So for example, after executing a first instruction, the instruction should not take the third for execution. Second instruction wanted to execute, after second only you should go to third, so that it is in order all the statements needed to execute. And not only that, when developing an algorithm, when developing a program, for execution there should be a reasonable time. Either it may be a 10 millisecond or 10 second or 10 hour, That's not a issue, but within the time the program wanted to give the result. Okay, indefinite execution time the program cannot take. So these are the features are the what is called ideas coming under statements or instructions. And the next one is a state. The state is very important one, like variables. For example, before execution of the program, let us consider one value I equal to 0. Then during the execution, the I value can be updated. That means the state I equal to 0 is goes to I equal to 1 or I equal to 3 depends upon your program. And like this, instruction also will move from one state to the another state during the execution. For example, during the execution of the program, okay, let us consider, okay, before paying one customer, his okay, the paid status is unpaid. Clear? So because the customer till now didn't pay the money, so that unpaid state. The instruction status is unpaid. Once paid, immediately the state is changed from unpaid to paid. So the two states, unpaid, paid, or that is a state yes or no. And like this, okay, the different states depends upon the program execution. The meaning is that during the program execution, the state status will change from one state to another state. Depends upon the status, okay, the program will decide whether the execution needed to continue or needed to terminate. For example, I equal to 5, I giving a command to break. I equal to 5, break. Okay, if I becomes 5, okay, then the statement will be executed. That means break will be executed, so that execution will be terminated. So till I becomes 5, the program will be executed. This is the status. This is called state. So you can understand with this example. Okay. And the third one is coming under building block of algorithm is control flow statements. This is a very, very important statement. With this statement, the system, the program will take a wise decision. Okay. So the control flow statements consist of three types of statements. Okay. One is called the sequence control flow statements. Then second, selection control flow statements. And the third, iteration or looping control flow statements. So see this diagram, you can understand. The sequence control flow statement will be executed one by one. For example, let us consider three statements. First statement, second statement, and the third statement will execute in order. That is called a sequence control flow statement. And the second one is called a selection control flow statement. So see this diagram, so you can understand. The selection control flow statement, it has what is called a selection option. That is called a choice. It depends upon the status. Okay, I can go to the particular block for execution, or that is another block. So depends upon the condition is very important. Let us consider this flow chart. So the condition becomes true. Okay, this block will be executed. The block may consist of tens of instructions. Okay, this block will be executed. If the condition becomes false, okay, another block will be executed. So like this, two choices, two selection, depends upon the condition. Okay, a particular block will be selected for execution. Like this, so some situations may arise to write a program like this. At that time, we can use selection control flow statements. And the third one is iteration or looping control flow statements. So here, sometimes a programmer needed to execute set of tasks, set of instructions, that is a set of statements number of times. At the time, can use this iteration or looping control flow statement. So see here, this statement 10 tasks. Okay, all the 10 tasks needed to execute under the condition. Okay, so for this purpose, we can use iteration control flow statement. So the condition becomes true. Okay, this block will be executed. Then again the condition will be tested. Condition becomes true. Again it will executed. That means that so the iteration or looping control flow statements will be executed set of instructions or a particular block. Okay, till the condition is satisfied. Once the condition becomes false, okay, it will exit from the block and it will continue further. So that is the control flow statements. As this is a very important for okay, algorithm designing or the strategies for developing algorithms, we will discuss with a suitable example later on in this video. Okay, next one is the function. As far as function is concerned, okay, it is a great methodology because with the functions we can solve very complicated problems. Means that if it is one problem is complicated, the problem can be sliced into smaller problems and each smaller problems can be solved one by one. It is an independent task. So the complicated problem is slicing into small task. The small task may be small functions. Okay, and all the functions are independent and parallelly we can execute. For example, so if you are conducting a one function, okay, at our institute, okay, one group, okay, can create a banner, second group can create food arrangement, third group can focus what is called inviting a guest like this. So different groups will take care of different responsibilities so that all the tasks will be solved, okay, independently and parallelly. So for like this you can understand the function. Okay, so as far as the function is concerned, okay, it will help, okay, to correct the error, that is called easy to debug. And the second one is, okay, function will help to reduce the program size. How it is possible? So for example, let us consider a one program, okay, that is a complicated project, is a large project where assume that 25 instructions, same 25 instructions needed to execute in 10 different locations of the project. Okay, imagine that no functions. For example, in the first required position location, I wanted to call all the 25 statements. After that, during that is another demand, the same 25 statements wanted to copy again for execution. Like this, okay, the same set of instructions, sometimes we wanted to execute a number of times during the program. At that time, instead of copying the same statements, we can create a one function. And whenever if you wanted to execute the 25 instructions, I can call the function. So that, okay, the size of the program will be reduced. You know very well, once the program size is coming down, obviously that is execution time also will come down. So that will help, that is a memory usage and execution time also. And because of this, we will achieve better reusability. And not only that, as the complicated problems is sliced and small functions we created, if any problem, any error in the particular function, it is convenient to correct the function. That means convenient to correct the error in the particular function. So that also possible, that is called modularity. Like this, the functions has numerous advantages. So whenever you are writing a program, we wanted to effectively handle functions so that, okay, error debugging is very easy. It will help to reduce the program size, that will help to reduce the execution time and the memory complexity also, and the better reusability also. Like this, lot of functions and all there. So one example is also given for functions. It is very simple understanding. So I wanted to add, okay, two numbers. For this function, I have created a function. See, two numbers read A and B. Then A and B is passed here. After executing this one, the function will be called. Immediately, the condition will come down here. Okay, condition will come down here. Okay, this function will be executed. Okay, then for example, A equal to 10, B equal to 10. Okay, 10 plus 10 will be added and the result is stored here and the result is returned here. Okay, then after that, okay, the fourth step will be executed. That means that the result will be printed. This is the one example of function. So this is not effective function. Let us consider, okay, the function is used for thousands of group of statements like this. For example, 10 and 20 I wanted to add, 100 and 200 wanted to add, 1000 and 3000, like this different group of set of two data I wanted to add. At that time I can use the same function. I no need write, okay, different codes for adding, okay, for all those data because the procedure is the same. So like this, so under that is a function we can discuss lot of strengths. So during a program development, during a coding side, so I will demonstrate okay the strength of functions further. Okay, now we will focus the control flow statements with the proper examples. Okay, so already I told you control flow statements under that's a building block of algorithms. Okay, the sequence structure is the first model. So I told you sequence means the instructions will be executed one by one. See, the step 1 first statement, step 2 second statement, step 3 third statement, okay, step 4 another statement, like this going on. Okay, under the sequence structure all the statements will be executed one by one, needed to execute also. At that time we can use the sequence structure. And the other one is a selection structure. I already told you selection means we have a choice. Okay, we can take a decision to execute either this part or that part, like this, where we can use the selection structure. See here, that is a condition. The condition becomes a true, group one group, condition becomes a false, another group, and like this it will go. So one algorithms, okay, so it demonstrating selection structure. See, the algorithms is designed for find the biggest of two numbers. Okay, so first one is okay, read the two numbers value, a value and b value, it will collect from user. Then after that comparison, if a is greater than b, if the condition is true, this block will be executed. The condition becomes false, okay, the another block will be executed. So two choice depends upon the status, depends upon the condition. Either the first block will be executed or the second block will be executed. So whenever we have a choice or we wanted to take a decision, choice depends upon the input condition, we can use selection structure. So some statements also, if statement, if else statement, else, lot of statements and all there, we will discuss during coding part. And next type, okay, of that is condition is, model is, control flow structure is iteration structure. So iteration, I already told you, set of instructions will be executed number of times till the condition becomes satisfied. So according to this flow chart, the condition is satisfied. Let us consider now I equal to 1. So the condition is true. Okay, this set will be executed. Then okay, I is incremented here. Okay, now I equal to 2. Condition becomes true. The set will be executed. Now I equal to 3 after executing this one. Okay, like this, okay, 10 times this block will be executed. 11 also will come. So I, okay, that is here according to this 10th side, okay, 10 is less than 10. The condition, okay, is not true. Let us consider I equal to 10. I less than 10 is not true. At that time, okay, it won't execute. It will come down here and it will exit, our remaining statements should be executed. Like this, whenever we wanted to execute a set of instructions under a particular condition, we can use iteration structure or looping structure. Okay, that is a for loop statement is there, while loop is there. So where, okay, we will enjoy iteration structure. We will discuss during the program side. And the final model is called recursion. This is the very good methodology, okay, to increase execution time, to minimize memory size as reusability happens here. What is the recursion? The function itself will call, okay, the same function and it will call number of times for a particular execution. That is called recursion. See here, so that is a one function. The function, okay, is calling a recursive function. Okay, the function is calling a recursive function, and okay, the recursive function is executing here. Inside the function call itself again with the different conditions, so that okay, the function is executed number of times. Okay, that is called recursive function. The function call its name itself number of times. Okay, that is called recursive function. So see this example, you can understand this is a suitable example for recursive function. So the program, this algorithm is developed for factorial calculation. Okay, so that is read the number. For example, let us consider n equal to 5. Then after that the function is called, factorial function is called. Okay, immediately, okay, the function is, control is come down here. Okay, because of this function the control is come down here. Now okay, n value is 5. So with this condition, okay, here it testing if n equal to 1 then return 1, okay, it won't return 1 because okay, n is a 5. Else okay, condition is coming, okay, f equal to n star, again the function, the same function is calling here. So what the calling, okay, now here n equal to 5, here okay, n minus 1, so that factorial of 4, with the factorial of 4 again the function will be called. Okay, next time will be executed, third time will execute, fourth time will execute till okay, n is equal to 5, so that 5 times will be executed. So this is called recursive function. It is a great function where we are using reusability, where we are achieving what is called time complexity, and that is memory complexity also. So recursive mechanism is a great mechanism to improve the performance of algorithm. And like this, learners can explain all the points under building blocks of algorithm or various strategies to develop the algorithms. My dear learners, watch the videos again to understand the concept clearly and okay, write examination effectively to score highest mark. All of you, good luck. Thank you for watching this video.